Hello and welcome, UCSD class of 2027. My name is Siro Zhang. I am a second year at UCSD data science. And so today we're going to go over a very introductory class into computer coding. In particular, we're going to look at a computer language called Python. Now, for those of you that may have some experience already with coding, this is going to be a very easy and kind of a basic class for you to introduce Python to. If you come from a different language like Java or C++, this is going to be your introductory class into Python as a computer language. Now, what this class is not, it's not going to be really your formal full-on lecture on computer coding. A lot of the topics we're going to go over today deserves their own 30-minute, 40-minute, 50-minute lecture on to explain the whole story. Now, with our times of purposes in this 30-minute lecture, we're just going to kind of briefly go over everything so that you can just get started playing around the code yourself. So basically, we're going to gloss over a lot of topics. And at your time in UCSD, with classes like DSC 20 and DSC 30, they will give you a much more formal and detailed introduction into these subjects. So to kind of start, I've been kind of talking about Python. So what is Python? Well, Python is a computer language that has been recently really popular in the field of data science and data analysis. Now, if you go on Google and search up what is Python, the definition you're probably going to get is that Python is a interpreted, object-oriented, high-level computer language. So what does that mean exactly? Well, think of it like this. We as humans, we have our own language. Some of us speak Japanese, some of us speaks English, and some of us speak French. Now, computers also have their own language too. Computers use their own binary language to talk to one another and communicate with themselves. Now, just like I can't understand, let's say, Russian, most people can't really understand computer languages. So it won't do any good. Let's say if we want to tell the computer to do a set of instructions, it won't do any good to talk to him in computer language directly, because that takes way too much effort and is way too complicated. So what we do instead is we have this kind of intermediate language. In this case, computer languages like Python. Now, Python is a high-level programming language. This basically just means that it is closer to what humans can be. In this case, it is closer to English. So what's going on behind the scene is that we are typing in Python, the language that is more familiar with our human language, to give a set of instructions to the computer. Now, along the way, there's going to be this thing called a compiler that is going to compile this line of code. It's going to change it into something that a computer can understand. It's going to change it to in their language. So essentially is that we are typing in instructions through Python and then translating it so that computers can take out the task that we tell it to do. So that is a very brief definition of what it is. When you go into DSC 30, they're going to explain this in way greater detail. It's going to kind of tell you the entire process of how, our coding language turns into computer language. For our time's sake, you can take that just take this analogy of like this language translator thing. So for a lot of you that may not have prior experience with computer coding is going to seem kind of complicated. When you see these giant blocks of code, you're going to think it's very intimidating to look at. Now, the reality is that it's not really that scary. Throughout your time at UCSD, you are going to write a lot of code. You're going to learn a lot of code, you're going to write a lot of code, and you're going to get very good at it. So it's really just a time process. And after a while, you're just going to look at this code and it's just going to be very, very simple for you. It's not going to be as complicated from the very beginning. Okay, so for today's agenda, we're just going to briefly go over some really basics. We're going to quickly go over the print function in Python. We're going to go over Python's basic syntax. We're also going to go over numeric data. The numeric data in Python is kind of split into three integers, flows, and like complex numbers. We're not really going to dive into that for now. Like I said, a lot of these subjects requires their own 30-minute session. We're not really going to go over that in depth. So for now, just treat them as kind of like all just numbers, which is what they really are. We're also going to look at some basic math operations you can do in Python. We're going to look at variables. And towards the very end, we're going to go over a very basic and quick introductory into what strings are. So these topics are designed so that once you learn these things, you can just start writing some code by yourself on your free time. It's to really just to get you started, get your hands dirty on into your introductory into computer coding. Because coding is one of those subjects that, although it's great and all that you go to a lecture and you listen to your prof explaining these new topics, it's very important for profs for you to listen these understand these kind of vocabs, these new different types of algorithms, etc. But in the end of the day, it won't really do any good for you to know all of this without you actually doing the code, by yourself. It's really one of those things that it's like driving. It really requires, you can do as much as driving tests, like knowledge tests as you want, but in the end of the day, it really requires you to actually, put your hands on it and start doing it to really get good at it. So, like I said, today's lecture designed for you to get started and just to play around with it and see what you can do with Python. So without further ado, we're just gonna kind of start. Okay, we're not gonna be using an actual. Sorry, let me from the beginning. We're not gonna be using an actual. We're not gonna require to download anything. The setting up process for Python is slightly bit complicated and tedious and time consuming. For simplicity, we're just gonna use a online compiler. In your DS20 class, your professor will go very like step-by-step tutorials on how to set everything up. But for our time's sake, for you to just get started, we're going to use an online one that people have already prepared for us. So just go on Google and search up online Python compiler. And and you're gonna let you just, and then you can just find all of them is pretty much the same. We're just gonna look at the first one, program IZ. That's the one I like to use, but all of them behave the same. So what we're gonna do, just copy me, follow along for now. We're gonna type in print brackets hello world. Okay. So what is going on? We're just gonna press run and then we get this. So what is going on? So here we're using the printing function. So what print does, like the name implies, it is printing whatever's inside this bracket into our output. In this case, it is printing hello world into our output. We can also change this quite a bit. We can say, I love coding. And if you press print, it's going to print out I love coding. So that's basically the gist of how we're going to output and show our outputs and stuff. Now, instead of printing this, we can also make it print some numbers. Let's say we want to make it to print the number 1. We press run. It's printing the number 1. Here, what we have is a numeric data. In this case, the number 1. Numeric data are very interesting because it's like math. You can do what you would do with math with them. So in this case, we can actually take our 1 and then we add it to another 1. So what's going to happen? I'm just going to run this. It's going to give us 2. So what is happening? Well, it's taking, just like, math, it is taking the numeric data of 1 and then adding it to another 1. And then this gives us, and then this combined value, which is 1 plus 1 equals 2, is getting printed out with our print function into the output. So yeah, so it's gonna follow the basic rules of math. We can also do 1 plus 2 or 1 plus 3. Hey, it's just like math. You make it do like some more difficult problems. We can do like 100 plus 3, 103. We also have, just like we have additions, we also have subtractions. We can subtract 10 from 3, so give us 7. So for multiplication, we're gonna use the asterisks, or I like to call them the star symbol. So 10 times 3, 30, print it out, boom, over here. We got a 30. For division, we're gonna use the backward slash. And it's gonna print out 3, 9 divided by 3, which is 3. Now you might notice that our result has the decimal key. Like I mentioned before, numeric data is split between like different types of numeric data. This is technically a different type of numeric data, but for our types of purposes, well, it's just 3. So we're just gonna assume that it's 3, which is what it really is. We also have power, so like 2 to the power of 2. For power, we do use 2 asterisks, 2 star symbol, and to indicate that it's going to be, 2 to the square, which is going to be 4. You get like 3, which is going to be 9. Same math equation. Now, the math equation here, when you do these operations, they're also going to follow our basic, rules of operations in math. So let's say if we were to do 1 plus 2 times 3, you can take a guess of what it is. So it's going to be not 9, but 7. Math operations, it's going to, multiplication comes first. It's going to multiply 2 and 3, giving us 6, and adding it to 1, giving us 7, and then printing it out, giving us 7 on the output. Brackets also exists, follows the same structure as basic math. So in this case, 1 plus 2 times 3. So 1 plus 2 equals 3, and then 3 times 3 equals 9. So that's the gist of it. I'm gonna close this actually. Okay. So that's the gist of it. So it's basic math equations that we can do in Python. We can also have 2 print symbols. So here's where our like I said, the syntax comes in. So let's say we do this. Python, just like we read top to bottom, Python also reads top to bottom. So in this case, it's going to read whatever's on top first. In this case, the print function that's printing 3, 1 plus 2. It's going to read that line, print it over here, followed by the second print, and then printing it out. So that's the very basic syntax. So it's going to be reading top to bottom. So now we're going to make things a little bit more interesting. We're going to introduce a variable. So let's just do x equals 1 and y equals to 2. So, oh, sorry, that is not Python language. So what is going on here? So let's say we print out x. And let's just see what's going to happen. It's going to print out the number 1. So what is going on? So notice this equal sign. What we're doing is that we are assigning, we're declaring this variable x and assigning it to the value 1. So these are what we call a variable. A variable is kind of a memory address to a certain value. That's a kind of a more professional definition of it. But think of this as, what we do in algebra. We have x and y's in algebra, and you know how these x and y's represents a number. So in this case, it's the same thing. We're taking our x, we're assigning it to 1, and then we're taking our y and assigning it to 2. So when we print out x, it's not going to print x. It's going to print out what x is assigned to. In this case, the number 1, which is our output. Why variables are important? Because we can also play around with variables. So let's say we add x and y together. What is going to happen if we press print is going to give us the number 3. What's happening is that we're adding x and y. Since x is the variable for 1 and y has the value of 2, we're actually adding 1 and 2 together and then printing it, which is going to give us the number 3. So variables are very important because they allow us to kind of modify our function a little bit over here. So let's say we want our Python code to find the area of a rectangle. Let's say your math teacher, for some reason, gives you like 20 questions about like how to find the area of a rectangle. Gives you like 20 size, 20 lengths, and then you have to calculate everything. So what we can do, we can assign a variable. Let's just call it length. Let's say our goal was to find the length was going to be 3. And then the height. Let's say the height is going to be 4. What we can do is area is height times length. Let's say we do this. And it's going to give us the answer, 12. So, like I said, these variables represent these numbers, but we can use this. We can also change this. Let's say we were to change it to 12. It's going to give us the answer right away. So this is going to help us, automate some of our tasks. We can make this number really big, and it's going to give us the answer right away. Let's say we were to do something more complicated. Let's say we're not going to do rectangles because rectangles are pretty simple. Let's say we're going to do the area of a triangle. If you don't know area of a triangle, it's height times length divided by 2. So we have to modify our function a little bit to 2. And then boom, it's going to give us the answer right away. So this is where the real power of computer coding is that it can help us do these very tedious tasks at a very fast and accurate speed. And it's able to do this at like insanely large number. Let's do something like this. And it's going to find it right away. So, instead of having us to kind of, do it ourselves on paper, which is going to make a lot of mistakes and it's going to make your brain hurt, or let's say doing it with a calculator, which might take too long, we can use this to do it instantly. Now, let's say we make it even more complicated. Maybe like area of a rectangle is not that impressive. Sorry, area of a triangle is not that impressive. Let's say we want to find the hypotenuse of like a Pythagorean triangle. We want to use the Pythagorean triangle. A squared plus b squared equals c squared. We want to find the side of a Pythagorean triangle. Let's do a equals 4. Let's say one of the sides is 4, and one of the sides is 3. Like I said, mentioned before, power is going to be 2 asterisks. So square of 2 plus the square of b, and then this entire thing we're just going to bracket it square root. If you don't know what square root is, kind of represented with power, is going to be 1/2. If you remember this from pre-calculus, so when the power is 1/2, it's actually square rooting it. So what we have here is our formula for the Pythagorean triangle, and it's going to give us the answer. Oh, that is wrong. Oh, sorry. Order of operations is wrong. My bad. Okay, yeah. So what is going on? So we're gonna see so now it's gonna give us a somewhat complex task and then do it right away. In this case, calculating, a squared plus b squared and square root. And this is going to be able, you can do this with any number. Let's say we make this very big. Scary right away. Let's say we make it a very complicated number. It's also going to calculate it right away. And it's it's always going to be correct. So like I said, about the purpose of computer is to kind of, computer science, the strength is to automate very tedious tasks. This will be something. So going back to the math teacher scenario, let's say your math teacher gives you 20 questions on using the Pythagorean theorem to calculate the sides. This is going to make your life a lot easier. All you have to do is going to have to change these variables, and then you're going to get the answer. So that's great and all. It's going to have so it's going to help you do your tasks at extremely fast speeds and with extreme accuracy. So, you can also play around with this. You can see what you can do with this model, and then you can see like what other types of functions or other math problems you can use to solve with what we have talked about today. Now, I want to go back to the syntax of Python and introduce to you an error that could happen. So let's say we move this A behind this prince. So now what's going to happen? Well, if you press run, you're going to see an error. The name A is not defined. So what is going on? Remember when I said Python reads top to bottom? So it's going to read the first line. It's going to see, we are assigning B to the value of 3. And then it's going to read the second line, which is the print thing. And then it's going to see the variable A. And Python is going to be confused by it because we haven't defined A yet, since it's reading top to bottom. So it's not going to know what A is, and then it's going to run into an error, even though we did declare A behind it. But since it's reading top to bottom, it cannot find this A. Thus, it thinks that it is not defined, resulting in what we have, this error. We can move A behind B or in front of B. It would both work because it reads what A and B is, assigning them before we use them in our print function. What this also means is, let's say we were to we assign A twice. What is going to do, let's actually just make this easier and then just print A. What is going to happen here is that it's going to overwrite the previous. It's going to start by reading A equals to 1, assigning A to 1, and then read the second line, and then seeing A to 4, and then assigning A again to the value 4. So now when we print A, it's not going to print 1 anymore. It's going to print the new value that we assign it to, which is 4. So yeah, remember this very important rule, basic syntax, top to bottom, and don't run into any of those errors. Okay, and with that, the last thing we're going to introduce are strings. So what are strings? So in the very beginning, when I printed hello world, you might notice that I put a quotation mark around it. This is to tell Python that what we have inside is a string. What string is that it is supposed to be a collection of characters, a list of characters. Think of this kind of like it's a word. Just like we have our numbers, now we have our words. So these strings are gonna behave a lot differently than our numbers. So let's say if we were to add two strings, let's say hello plus world, what it's instead going to do, it's going to print this out. So what it's doing is that it's taking our first string, and then when it adds to our second string, it is just combining them together. Notice how it's hello followed by world. So with this model, let's say we were to do this. We do 1 plus 1 again, but it's two strings. Then what do you think is going to happen? So instead, what's going to happen is that instead of adding, the actual number 1 plus 1, it is combining two characters of 1, which is going to give us 11. 1, another 1 combined together into two ones, a literal two ones, as represented by 11. So that's where strings differ from our new numbers that we had talked about. So going back, let's comment out a little bit. So, okay, let's see. Let's bring back our length and heights. So what we can do is we can use these strings to make our result look a little bit prettier. So the area of the rectangle, the area of a triangle. So now we can slap in these formulas again. Let's do area of a rectangle is going to be length plus height. Area of a triangle is going to be length times height again, but divided by 2. See that? Now our result looks a lot more prettier. So it is taking our first one. It's printing this out, top to bottom, calculating our area of the rectangle, printing it outside, and then printing out the area of the triangle, calculating it, and then printing it out. So that's a lot more, visually appealing. So that's why I say, and then with this formula, you can start kind of experimenting. Let's say we want to do like the area of a circle. If the area of a circle. We need a new value. Let's call it radius. Keep doing that. If you remember from math, radius square times pi, which is 3.14, and it's going to give us another one. So think about what we talked about today. Think about what you could do using this kind of format. And I want you to, after this lecture, to just experiment and play around with it and see what you can do with the topics we talked about today. See what other math problems you can automate with this structure. And like I said, in your time at UCSD, you are going to go much more in depth. But for now, I want you to kind of not be intimidated by computer coding. And I think the best way to do that is to kind of, have fun. Just play around with it and fool around with it and see what you can do with it. So with that said, okay, well, that's kind of it for today's short lecture. If you see me across campus, feel free to say hi. And if you have any questions when you ran into me, feel free to ask. I'm always happy to answer any questions. And yeah, enjoy your time and welcome to UCSD. I wish you the best luck in your time here. Yeah, good luck.